This is our second video in which we look at calculating the Surprisal values for Gilbreath performances. Today we will be looking at cyclic structures having cycle length 4. So let's begin. Given a standard deck of 52 cards, we will analyze packets of 4n cards that consists of n cards of each of the suits, clubs, hearts, spades, and diamonds. To facilitate graphing in Desmos, the variable x will be used in place of n. In other words, the functional variable x that we will use represents the number of clubs, or hearts, or spades, or diamonds in a packet consisting of an equal number of cards of each of the 4 suits. This means that the packet size for a given value of x is 4x. Since we are modeling possible scenarios for a deck of 52 cards, of which 13 are clubs, 13 are hearts, 13 are spades, and 13 are diamonds, the permissible values of x are positive integers between 2 and 13 inclusive. Therefore, when interpreting the various graphs, we need to mentally multiply the value of each x-coordinate by 4 to obtain the actual size of the packet of cards being represented. Although each of the following functions only makes sense for discrete values of x, namely positive integers, Desmos uses a general factorial function, the gamma function, to draw a continuous graph that connects the corresponding discrete points in the plane. So let's go ahead and build our Surprisal function for a cyclic packet in which there is a cycling through of the 4 suits in some consistent order. So here we go. Cyclic structures having cycle length 4. For example, if we were to order the entire deck in this fashion, namely a club, heart, spade, diamond, followed by a club, heart, spade, diamond, and so forth, that would constitute a cyclic structure having cycle length 4. Where already mentioned, we will let the variable x represent the number of clubs, hearts, spades, and diamonds, which means that our total packet size is 4x cards. The total number of ST, in other words, suit packets, is the following: 4 factorial times the quantity x factorial to the 4th, where x is a positive integer between 2 and 13 inclusive. So this truly does give, for a given value of x in this range, the total number of distinct orderings of a packet of 4x cards where the suits repeat in some consistent fashion. Now that's in contrast to the total number of permutations of these 4x cards, which comes out to be the quantity 4x factorial. Okay? So to obtain the probability that we would, by chance alone, randomly shuffle this packet of 4x cards and find that it has a consistent repeating pattern of the 4 suits, we'll take this quantity here and divide by the total number of permutations of those cards. In other words, given the above 4 times x cards, the probability that a random mixing of these cards would yield an ST packet is the following. Consequently, the surprisal of such a packet occurring by chance alone is equal to log base 2 of 1 divided by the probability of obtaining such a packet, which is equal to log base 2 of this quantity here. And as you can see, the 1 divided by the probability, where the probability is listed here, has just flipped the fraction. And that's what you'll find on the left-hand side of the screen here, the first function. I'll go ahead and just highlight the blue here. We'll focus on that one. Now, as we saw in the previous video dealing with cyclic structures having cycle length 2, the surprisal, or likelihood of a random shuffling of the deck resulting in such a highly structured organization of the cards is very unlikely. In fact, we can come down here on the chart. Remember, our X values need to be multiplied by 4 to get the total packet size. So 13 times 4 is the 52 cards in a standard deck. So the chance that you would just mix those cards thoroughly and then lay them out and find that there is a consistent repeating pattern among the 4 suits, the surprisal associated with that outcome is 90 bits. 90 bits of surprisal. So we're probably not surprised that this would be so incredibly unlikely to happen. But remember, when it comes to Gilbreath performances, we begin with a cyclic construction, and then we Gilbreath shuffle that packet, okay? So that's really what we're interested in now. We're interested in what happens when we randomly deal out a number of cards and then riffle shuffle those together in a haphazard and messy way. What kind of structure results after having done that? Or is all structure destroyed? Well, the Gilbreath principle says, no, there is tremendous structure that remains after that process, which is absolutely amazing. Okay, so that's really what we're focused on here. So let me go ahead and highlight the second surprisal function. And let me point out now that the subscript is GST, where the G stands for Gilbreath, shuffled. And the ST, of course, is our organization of the cards where it cycles through the 4 suits in some consistent fashion. And I want to remind you that the expressions at the heart of the probability function for these cyclic structures having cycle length 4, as well as the expression for the Gilbreath shuffled version of that packet, can be derived using the fundamental counting principle, which is also called the multiplication principle. In other words, the tools needed to derive these formulas are not overly sophisticated or esoteric. So let me just show you the best I can that I have set up the entire deck as a cyclic packet with cycle length 4 that cycles through all 4 suits in a consistent ordering. So I have clubs, hearts, spades, diamonds, clubs, hearts, spades, diamonds, all the way through the deck of 52 cards. Now, as we've already seen, it's extremely unlikely that a randomization of a deck of cards would result in such a highly structured organization of the cards. That's where the 90 bits of surprisal come in. So virtually impossible. But the Gilbreath principle, nonetheless, involving some significant mixing that is the result of random choices and a random interlacing of the cards, nonetheless results in a structure that is highly unlikely. Okay, so here I have a cyclic deck with cycle length 4. So we can now perform a Gilbreath shuffle. And remember, a Gilbreath shuffle consists of just 2 steps, okay? The first one is you reverse count any number of cards. So you just deal them to the table. The spectator can decide this. So you deal until the spectator says, stop dealing, okay? And it's kind of nice to have about half the cards, but you don't have to. You could deal 1 card or all of them to the table, I suppose, if you want. The conclusion of the Gilbreath principle would still apply. Okay, so we've reverse counted a random number of cards decided by the spectator. At this point, we can do a riffle shuffle of these two halves. You can have the spectator do this. Now, in the last video, I actually did a rosette shuffle, which is perfectly fine as well. That's where I put them on the table and I kind of spun them and then brought them together in kind of a random fashion. Okay, so that's one way to do it. Another way is just a traditional riffle shuffle. Okay, and now as you can see, that is far from a perfect shuffle. I have no idea. In fact, no one knows how these cards have now just been interlaced. No one knows, okay? But the Gilbreath principle guarantees that tremendous structure still remains, which is absolutely mind-blowing. So what is the conclusion of the Gilbreath principle for this particular organization of the cards? Well, it's the following, that if we take off sets of 4 cards from the top, lay them out, we will get exactly 1 card of each of the 4 suits. Here's the next set of 4, spades, diamonds, clubs, hearts. Next set of 4, clubs, diamonds, hearts, spades. Next set of 4, diamonds, clubs, hearts, spades. So you can even see that they're in different orders here. Hearts, clubs, spades, diamonds, and so forth. This will be true for each and every set of 4 cards taken from the top. Absolutely amazing. You saw how those were shuffled. They were interlaced in a completely unpredictable way. How is it possible that we could get this kind of structure remaining after that random dealing out of a number of cards and the random interlacing of those cards? Well, that's the Gilbreath principle. Okay, it guarantees that this will happen, which is why it's one of the most remarkable principles in all of mathematical card magic. Okay, so showing the spectator that will absolutely blow them away if they are the ones that dealt a certain number to the table and they were the ones that riffle shuffled them in whatever way they chose. And in fact, let's go ahead and just see how unlikely it is for a, quote, shuffled deck of cards to have that degree of structure. Well, that's what we're looking at here for the Surprisal function with the subscript GST, which means Gilbreath shuffled packet, in which the suits repeat in some consistent order throughout. And since we've done this for the entire deck, we can go all the way down to an X value of 13. Remember, X here represents how many we have of each of the 4 suits, which we have 13 of them. So if we come over here, we see a Surprisal value of 35, almost 36 bits. What does that mean again? That means that if we had 36 fair coins, toss them high into the air, and then call heads on all of them, and then watch the coins hit the table and bounce and eventually settle down, and every one of those 36 coins is heads up, and you called it before the event occurs. And so what I just showed you with Gilbreath shuffling and then revealing that every set of 4 has 1 of each suit has the same Surprisal value as tossing those 36 coins, calling heads, and having all of them land heads up. Okay, unbelievable. And the other interpretation we had for this kind of Surprisal, if we stick with 36, we could round it down to 35 if that feels better. Okay, why don't we be conservative? We'll round it down to 35 this time for our interpretation. The surprise in witnessing what we just saw with this Gilbreath performance is the same level of surprise one would experience in taking a 35 question true-false exam in which you randomly guess on all of the questions, but nonetheless, you finish with a perfect score. You get every one of those 35 true-false questions correct, despite the fact that you just randomly listed T, F, F, T, and so forth. You just guessed on all of them, but you got 100% on it. The level of surprise associated with that amazing outcome is the same level of surprise as what we have just witnessed in displaying that all sets of 4 from the top consist of exactly one club, heart, spade, and diamond. And it's the reason that if you show a spectator this performance, you can just see on their faces the degree of utter surprise, especially if they are the ones who did the dealing to the table and they are the ones who riffle shuffled the deck. If they don't believe in real magic at that point, I don't know what it would take to convince them that something remarkable has occurred. Well, something remarkable has occurred, but it's still mathematical in nature. And that's why the Gilbreath principle continues to be one of the most important principles and discoveries in all of mathematical card magic. Okay, now of course you can work with smaller packets if you like. You don't have to have the whole deck set up, okay? So why don't we do one more of these? Let's say you're only wanting 10 bits of Surprisal, which by the way is a lot still. 10 bits of Surprisal is the level of surprise one would experience in tossing 10 fair coins into the air, calling heads on all 10 coins, and then watching those 10 coins all land heads up. In fact, try that sometime. Grab 10 random coins and flip them over and over and over and see if you can ever get heads up on all of them. And most likely, you won't. And if you do, most likely it's going to take a very, very long time. Okay, so why don't we go ahead and we'll kind of view it this way. We'll choose a level of surprise we would like to achieve in the minds of the spectators, and then we'll build a cyclic packet and Gilbreath shuffle it, which will result in a Surprisal value of just over 10 bits. Okay, so here, for 10 bits of Surprisal, we're looking at an X value of 5. Remember, 5 is indicating how many clubs, hearts, spades, and diamonds you're using. So we multiply the 5 by 4 to get the total packet size. So we're looking at 20 cards, okay? So I need 5 clubs, 5 hearts, and 5 diamonds. So I'll take a club, a heart, a spade, a diamond. I do want to point out that you don't have to order them exactly in this order. You could do heart, spade, diamond, club, heart, spade, diamond, club. The key is you have to have a consistent ordering of those 4 cards. But I'm just putting them in the classic chased order. Clubs, hearts, spades, diamonds. Okay, so that's X value of 2. That's 3, 4, we're almost done. Okay, so we're going to work with just these 20 cards. Let me just show them to you. Okay, so we should have 5 of each of the 4 suits. So clubs, hearts, spades, diamonds. Clubs, hearts, spades, diamonds. That's 2. Clubs, hearts, spades, diamonds. 3. Clubs, hearts, spades, diamonds. 4. Clubs, hearts, spades, diamonds. 5. Okay, great. Now, just out of interest, what are the chances that if you had these cards and you just mix them, what's the chance that they would come out to be exactly a repeating pattern of the 4 suits? Well, that's where the first surprisal calculation comes in. Essentially, it's where we start. So we can take a look at it here. It would be almost 29 bits of surprisal. Oh, wow. Not very likely. Now, what we're looking at is the fact that we're going to now, in the minds of the spectator, mix these cards beyond the knowledge of anyone, and it's because of the random choices that they're going to make. I cannot know, you cannot know ahead of time what their choices will be. That's the key. Okay, so we will now Gilbreath shuffle this cyclic packet that has cycle length 4. Okay, what does that involve? Just 2 steps. That's all you need to remember. You deal out any number of cards that you like or the spectator likes. Okay, so maybe they stop there. And then you riffle shuffle these together like I just did. Now, when the packet is small, as is the case here, a wonderful alternative is a rosette shuffle. You just spin the cards and then just bring them together however they, will interlace, okay? And as you might imagine, no one could know how these cards are interlacing among themselves. No one, okay? So I have no idea how they've interlaced, okay? Now, we finished our Gilbreath shuffle, okay? So we started with a cyclic packet. We performed the Gilbreath shuffle. So now the Gilbreath principle is in force. Well, what's the Gilbreath principle? Well, it's what we've been doing. That's where if you take off groups of cards that equal the cycle length of the cyclic packet you started with, the cycle length was 4, we should get one of each of those distinct elements here, a club, heart, spade, diamond, in some order. Doesn't matter, we won't know the order, that's okay. But we get exactly one of each. So you will never ever see like 2 diamonds in here or 2 clubs, okay? Okay, so let's just check this one too. Looks just fine. Perfect. Check this one down here. I think there's room. There you go. One of each suit. And then the final one, one of each suit. Okay, very, very good. Well, what kind of surprise would a typical spectator experience in witnessing this, especially if they are the ones that dealt out the cards and then rosette shuffled them together? Well, that's where our surprisal calculation comes in. So remember, we're at x = 5 because we had 5 of each suit. Now we're coming over here to the Gilbreath, so G, Gilbreath shuffled packet, and it's just over the 10 bits that we chose ahead of time. So the level of surprise one would likely experience in watching this performance and seeing this conclusion is the same level of surprise you would experience in watching 10 fair coins tossed into the air and having someone else predict that they're all going to land heads up. And you're thinking, yeah, right. But then they do all land heads up, just as the person claims. So that's the same level of surprise as they would experience in watching this successful performance here. Okay? Or in terms of a true-false quiz, it's like randomly guessing on a 10-question true-false quiz and getting 100%, even though you had no clue. Talk about Lady Luck being on your side. She would certainly be on your side to have aced that 10-question true-false quiz, and you had no idea what the answers were. Okay, so that is a look at calculating the surprisal values for a Gilbreath performance in which we have a cyclic packet with cycle length 4. Okay, and also I want to point out that in the description below, I will be listing these Desmos activities that I'm using. Okay, so if you just go to the description below, you'll find a Desmos file that you can access. It'll take you to desmos.com and bring up this exact activity. And so you can play with this and work different versions here, different packet sizes. And then you can look up, oh, well, what's the surprisal value for this particular performance? Okay. And then you can graph them. I guess one thing I didn't mention, I also have this function that shows the difference between the original cyclic packet and the Gilbreath shuffled version of the packet. So that's what this purple line is showing. It's showing the difference between them. Okay, I appreciate you watching, and in the next video, we're going to be looking at cyclic packets having cycle length 13. So this will be a packet that cycles through the 13 values. I want to point out that the reason that we started with cyclic packets with cycle length 2, and then we went to 4, and now we're going to go to 13, is because they are preparing us for a Stebbins performance, in which all 3 of those important characteristics will be true for a single organization of the deck after it's been Gilbreath shuffled. Okay, which just sends the surprisal values ever higher. Okay, so I hope you join me in the next video dedicated to the Gilbreath principle and calculating surprisal values for such performances. So thank you again for watching.